Guys, so now we're going to be talking about limiting reactants and excess reactants, or you could call them excess or limiting reagents. They tend to use either term when they're referencing that. So how is the amount of product in a reaction affected by an insufficient quantity of any of the reactants, okay? So in chemical reaction, an insufficient quantity of any of the reactants will limit the amount of product that's formed. So think about when you're making a recipe and you buy a bunch of stuff in bulk. One item is always going to determine how much of that you can make, okay? So that's what we're talking about when we say limiting reactant and excess reactant. Now, if we went back to the s'mores lab that we showed you earlier, you would have seen that one of those three items is going to be limiting and one's going to be excess. So you should have already gotten that the chocolate was the limiting reactant and the marshmallow and the graham cracker would be an excess based on the number of s'mores you could make with each package, okay? So the same thing happens in a chemical equation, okay? So the limiting reagent is the reagent that determines the amount of product that's formed in a reaction, because it's going to limit how much can actually, once that limiting reagent is used up, the reaction stops. It doesn't go any further because it limited how much can be produced, okay? In the reaction of nitrogen and hydrogen, hydrogen is the limiting reagent, nitrogen is a reagent that is not completely used up in the reaction. The reagent that is not used up is called the excess, kind of like the graham crackers and the marshmallows, okay? Now, let's figure out in a chemical equation, if I know what I start a reaction with, I should be able to determine which one of those is my limiting and which one is my excess reagent. So this is how we're going to start this. So copper reacts with sulfur to form copper 1 sulfide according to the following balanced equation. What is the limiting reagent when 80 grams of copper reacts with 25 grams of sulfur? So we're going to have to set up two mass-mass calculations in order to figure this out, both solving for the same X, or the product of the reaction. So in the first one, I have 80 grams of copper, okay? Now, I'm going to react that with sulfur, and I'm looking to see how many grams of copper 1 sulfide is produced. So I'm going to start this out like a mass-mass problem. So I'm going to start out with 80 grams of copper over 1, okay? And then I'm going to put 1 mole at the top because I've got to convert into moles. And I'm going to put the molar mass of copper, which is 63.6 grams, okay, of copper. That's the atomic mass of copper. Next, I'm going to do my mole ratio, don't overdo what I don't know over what I do know. So I don't know copper sulfide, I do know copper. So I have a 1 in front of copper sulfide and a 2 in front of copper. Okay, so don't overdo, remember? Now the last block is going to be the molar mass of my copper 1 sulfide. 1 mole goes here. So I have 2 coppers, both at 63.6. So we would say 63.6 times 2 plus sulfur, which is 32.06. And that's going to give me a molar mass of 159.26 grams, okay? Now I'm going to solve my problem. So 80 times 159.26 divided by 63.6 times 2, and that's going to give me 100.2 grams of the copper 1 sulfide. So if I used up all 80 grams of copper, I would end up producing 100.2 grams of copper 1 sulfide. Now, let's look at the next one. This one's stating that what if I had 25 grams, I started the reaction with 25 grams of sulfur. So now I'm going to do another mass-mass calculations, but instead I'm going to use sulfur's mass to start the reaction, but I'm still looking for copper sulfide. So I'm going to set up another mass-mass, so I say 25 grams of sulfur over 1. I have 1 mole. I'm going to put the molar mass of sulfur, which is 32.06 grams. I'm going to do my mole ratio, don't overdo. So 1 mole of copper sulfide for 1 mole of sulfur. And the last block is going to be the molar mass of copper sulfide over 1 mole. So now I'm going to have 25 times 159.26 divided by 32.06, and I'm going to get 124.2 grams of copper 2 sulfide. Okay, so what does this tell us? Well, if I have 80 grams of copper, the most I can produce of copper sulfide is 100.2. The 25 grams of sulfur can produce 124.2 grams. We don't have that much because we're already limited at 100 right here. So the limiting reagent here is going to be our copper. It's limiting how much product can be produced. So in this case, my limiting, okay, oops, hang on. Okay, so my limiting reagent, okay, is going to equal the copper, and my excess is going to be the sulfur. And then by how much excess? Well, I would take 124 minus 100.2, so I would have, so much excess sulfur, okay? So I'm not going to use up all of my sulfur, all right? So that is how you figure out a limiting reagent problem, okay? Now, why that didn't erase. Hang on, y'all. Something happened weird. All right, so now let's do another problem here, okay? So, what if I had an equation of the complete combustion of ethene, which is C2H4, okay? So I have my reaction. If 2.7 moles of C2H4 is reacted with 6.3 moles of O2, identify the limiting reagent, okay? So, in this problem, I'm actually going to start out a little easier because I'm going to start with moles. So, in this problem, I have 2.7 moles of this, and this is going to be a little tricky, so I'm not going to be able to write that over there. So I'm just going to write over here. So if I start this out with 2.7 moles of C2H4, okay, and now in this equation, okay, I can pick, since they didn't identify, so that I only have I have 2 products, not 1 product, I can pick which product I'm solving for. So I'm just going to solve for water here to see how much water I produce, okay? So I'm going to say this over 1. So my smart board is not being very smart right now, so hang on. So if I have 2, yep, here we go. So I'm going to have to take a second break here and try to calibrate, if it'll let me. Yep, I'm going to have to go over here and calibrate. Alright, so sometimes the smart board is just not real smart. So that's alright, we'll just take a momentary break, orient the smart board. Okay, and now hopefully it will cooperate, and it may not. Let's try this one more time. And if not, we're going to end on that. Alright, so if I have 2.7 moles of C2H4 over 1, okay, I'm going to be looking for water here. So I'm going to go directly to my mole ratio. I'm looking, this is my X, That's my given. So I have 2 moles of water for 1 mole of ethene. And I'm just going to leave it in moles because it didn't ask for grams. So in this case, 2.7 times 2 is going to give me, drum roll, 5.4. And I don't know what that's writing. Moles of water. Now the next one, I have 6.3 moles of oxygen over 1. And then my mole ratio is going to be 2 waters. Oh, lovely. 2 waters. Let's try to write this a little lower. I don't use the smart board, just so y'all know. Yep, not doing it. So you have 2 moles of water and 3 of oxygen, so you're going to take 6.3 times 2/3 and get 4.2. So for this one you get 4.2, for this one you get 5.4. So oxygen is your limiting reagent in this problem. Alright, so now you guys are going to get a worksheet on how to do limiting reactants and excess reagents. Okay?